Using your periodic table, identify the last part of the electron configuration for the following elements. Let's try calcium. First thing that we're going to do is we're going to locate it on the periodic table. So here's calcium. Let me circle it. Now we're going to look to see which shell it's in, S, P, D, or F. It's in the red block, which means it has an s orbital at the end. How many electrons are in it? We're going to count over the s block. We're going to go 1, 2. So it's S2, meaning there's 2 electrons in the S shell. Now which S shell? We look at the period. For calcium, it goes 1, 2, 3, 4. It's in the 4th period, so the last part of its electron configuration is 4s2. Let's try another one. Okay, PD, palladium. First thing we need to do is locate it. So where's palladium? PD. Right here next to silver. So I'll circle it. If you look at the color, it's in the D block. How many spaces over? 1, 2, 3, 4, 5, 6, 7, 8. That means that there's 8 electrons in the D shell. Now what level shell is it? It's in the 1, 2, 3, 4, 5th period, but the D shell falls 1 behind. So 5 minus 1, it ends with 4d8. Now, what 2 exceptions occur in the periodic table? If you look at the periodic table, I have 2 rows circled. This row right here, which has chromium, molybdenum, tungsten, and seaborgium, and this row right here, which is copper, silver, and gold. Those should end in the following electron configurations: S2d4 and S2d9. But what happens is an element's much more stable when its D shell is full or half full. So instead of those, it switches. And everything in the row with chromium finishes with S1d5. It's more stable that way. And everything in the copper row finishes with S1d10 because it's more stable that way. So let's look at the last question. Look at the element potassium. What is its electron configuration? Potassium is found right here on the periodic table. It's in the S block, it's in the 1st position, and it's in the 4th shell. So it finishes with 4s1. If we go through the entire electron configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. How many valence electrons does it have? The 4th shell is its outer shell, and it only has 1 electron in there. What does this tell us about its reactivity? It's very reactive because it really wants to get rid of the 1 electron. Okay, question 4, we're also going to be using our periodic table. It says, which of the following elements would be smaller, have a smaller atomic radius, and why? If we look at the first one, we're comparing silver, or gold, and copper. So if we look here, here's gold, here's copper. So we need to know which one's smaller. As you go down the periodic table, your atomic radius increases. That's what it says off to the side. So the bigger element would be gold. Why? Copper only has 1, 2, 3, 4, 5 shells, and gold has 7 shells. So the reason it increases going down is because one of them has more shells. Now how about selenium or potassium? Here's potassium, here's selenium. Selenium is further to the right. As we go across the periodic table, the atomic radius decreases. So potassium would be your larger element. Why is that? When you have more electrons, you have more pull. It gets pulled in tighter to the nucleus.